Hey YouTubers, I hear you're looking for information about Mutex Locks. Lucky for you, we have all the basic information that you need. Hope you enjoy.
What is a lock? A lock is a device that limits access to a resource or a location. In programming languages, as in everyday life, you need a key to open a lock. Without permission, processes cannot gain access to the locked resources.
A key concept to programmatic locks is mutual exclusion. Mutual exclusion is simply a resource or location that only one entity can have access to at any given time. The man that brought this idea to programming was Edgar Dijkstra, a Dutch computer scientist who published a paper on this topic in 1965.
Taking our lock example a step further from a general lock where everyone who had a key was allowed to open the lock, applying mutual exclusion takes security a step further. This technique permits only one person to have the key to the lock at one time, and until they give it up, no one else can access it.
This type of lock is called a Mutex lock, which puts the two terms together, mutual exclusion. It is used to secure and protect a special region of code called critical section. The critical section is the area of code that two threads or processors share and both need to manipulate or change values of data in this section. Only after exiting its own critical section can the lock release to be used by another process.
If two threads running the same code were allowed to change shared variables at the same time, their outcomes are dependent on the order the variables change. For example, program 1 uses variable x, which has a value of 3. Each time program 1 uses x, it adds 1. Program 2 also uses variable x, and each time it uses that variable, it subtracts 1. If the two programs are running concurrently, the outcome of x would likely be different every time these two threads have finished. This concept is known as race conditions. A mutex lock prevents such varied outcomes.
A mutex lock is also known as a spin lock. This name comes from the repeated calls or attempts by threads to access the lock. Since there is no queue with this implementation, the only way a thread can access this lock is to repeatedly ask for permission.
When you have two threads attempting to access a single resource, the general pattern is to have the first block of code attempting access to set the mutex before entering the code. When the second code block attempts access, it sees that the mutex is set and waits until the first block of code is complete and then continues.
There are both hardware and software solutions to solve the issue of race conditions. Peterson's solution and semaphores are both examples, but a mutex lock is the simplest and easiest to implement. Here's a metaphor using 4 handsome men and a car.
Here we see 3 people, each representing an identical thread. The car represents the critical section. Each thread attempts to access the door, but only one may enter at a time. After this lucky thread gets to complete his task, the car is exited and the door is now unlocked for the next thread that gets to the door first.